Number 7, I'm going to go and explain how to do that. I've kind of worked out the steps, so kind of to save time. We have negative 3 square root of 3 plus 3i times negative 3 square root of 3 divided by 2 minus 3i over 2. So each color here represents a multiplication that I've done already. So negative 3 square root of 3 times negative 3 square root of 3 divided by 2 is indicated in the blue section. So that would be the first one. Negative 3. The next one is the red one, which is negative 3 square root of 2 times negative 3i over 2. And of course the green one is 3i times negative 3 square root of 3 divided by 2. And then I guess the yellow one would be 3i times negative 3 over 2i. And of course what I'm doing here is called the FOIL method. This is called the FOIL method. This would be the yellow one. If you notice on the first one, we have negative 3 times negative 3, which is 9. Negative 3 times negative 3 is 9, and then the square root of 3 times square root of 3 is 9. Square root of 9 is 3, so that's 27 over 2. The next one is negative 3 times negative 3 gives you 9 square root of 3i over 2. So that's the red one. And then 3i times 3i, 3i times negative 3 square root of 3 gives you negative 9 square root of 3 over 2. And you notice I put an x, that means that becomes 0. Negative 3i times 3i gives you negative 9i squared. Remember that I squared is negative 1. So that gives you 9 over 2, which gives you 27 over 2 plus 9 over 2, which gives you 36 over 2, since they have the common denominator. 36 over 2 is 18, so that is your answer, okay? So for number 10, we're talking about increasing and decreasing intervals. And when we're talking about increasing, decreasing intervals, we're talking about over the x value. So we know that we start at negative infinity and we work towards positive infinity. You notice that the red indicates a decreasing. At some point, it stops decreasing. Of course, that point is not included in the conversation of increasing and decreasing. It's just a point that it stops decreasing. For example, from negative infinity up to 0, not including 0, this function is decreasing. So we have from negative infinity to 0, it's decreasing, and then it jumps again. Starting at 2 on the other side, it starts decreasing. The union will bring these two intervals together, okay? So union means that we're bringing those two items together. The yellow indicate where it's increasing. So after 0, x equals 0, it starts increasing all the way up to 1. And remember, we're talking about the x values. So we're talking about the x values. We're going from 0 close to 1. So we don't ever reach 1. So it's increasing from 0 to 1. Of course, it jumps the asymptote, and it starts right after 1, 1 to 2. So the only one that satisfies this is A. Remember, these are not ordered pairs. Increasing from the interval, and I'm going to write that on top, interval. Interval from 0 to 1 and from 1 to 2. Decreasing, remember this is interval, from negative infinity to 0, and then from 2 to positive infinity. So The yellow indicates the increasing part of the graph, and the red illustrates the decreasing part of the graph. And we look at 11, and I'm going to use my pen to trace where it's decreasing. Right here, it is decreasing. It's decreasing. Once again, on this other side, after the asymptote, it's decreasing. And if I were to trace again, where is it increasing? It's increasing here at x equals 0. Of course, it jumps over the asymptote, and then of course it starts increasing here. So we have to describe the interval. Once again, you want to write this down. Interval means the x values over what x values. So when I say you need to find the interval, you need to figure out over what x values is it increasing or decreasing. In this case, it starts at negative infinity since we read from left to right. So from negative infinity, So from negative infinity to negative 1, it's decreasing. At negative 1, there is an asymptote. So the graph jumps the asymptote and then starts after negative 1 to 0. Remember, there's no brackets. So this is the decreasing. So the only one that satisfies that is C. Okay. Increasing after x equals 0, it's increasing, and then it stops right before 1, and then it jumps the interval. It jumps the asymptote, and it starts again on the right side, so it goes from 1 after 1 to infinity. Remember, brackets would mean that it includes, and we're not including. Remember that brackets means to include. And in this example, we're not including the transition value. So 1 is considered a transition value. Negative 1 is considered transition value. We're not including those values, okay? So once again, the answer to this is C, because we're increasing from 0 to 1, and we're also increasing from 1 to infinity. That's the red part. Decreasing is from negative infinity to negative 1, and also from negative 1 to 0. For 21, we're going to go ahead and find the inverse. Remember the way I explained to you, you're going to say y equals negative x plus 1 cubed. And then what you probably want to do is want to switch the x and the y. So you have x equals negative parentheses y plus 1 cubed. What you want to do now is divide by a negative 1. So you have negative x is equal to y plus 1 cubed. You're going to go ahead and get the cube root of both sides. So you have y plus 1 is equal to the cube root of negative x. What you can do here is, you know that the cube root of negative 1, if I get the calculator, just so I can show you, I'm going to minimize that for right now, just so you can see why I justify this. You have the cube root So you go to second, actually go to math, and here is a cube root. We know that the cube root of -1 will be -1. So you can always factor that -1. So you have -1 cube root of x equals y plus 1. Subtract 1 from both sides. So you have the cube root of x minus 1 is equal to y. Remember, you can't subtract what's in the radical and 1. And since we're talking about inverse, the inverse function, it's going to be the cube root of x minus 1. So your answer is A. Okay. And I'll leave my calculator there since we're going to be doing transformation in a little bit here. Okay, let's go ahead and go to number 22. And once again, we're trying to find the inverse. So we have y is equal to -4x plus 8. At this point, you want to switch the x and the y. So you have x is equal to -4y plus 8. At this point, you want to solve for y. Subtract 8 from both sides. So you have x minus 8 is equal to -4y. And just so I can make sure that we have this in order, we have -4y equals x minus 8. I kind of switched because I want to work with the left side. The next point is to divide by -4. -4 divided by -4 is 1, so you have y is equal to negative x over 4 plus 2, or since we're talking about inverse function or inverse relation, the inverse will be negative x over 4 plus 2. So the only one that satisfies that is D. D is the answer. Okay. For 26, it says describe the transformations necessary to transform f of x to g of x. So just like I've taught you before, on your graph, on your paper, you're going to sketch x squared. That's the parent function. So on your paper, I want you to do this. You're going to go ahead and just sketch this. This is the parent function. This is your y-axis. This is your x-axis. Now, that -1 is going to do something. Both of these are going to do something. That -1 here is going to shift it down, and this -1 is going to shift it to the right. So I'm going to go ahead and I'm going to type in the equation x minus 1 squared minus 1. And I do like this feature that the TI-84 has. So you can see the trace. It will actually trace it for you. Maybe I like this one better. The one that's dotted, maybe you can see it better. So I'm going to go ahead and graph it. And then you can see that the transformation, it goes to the right. Did I say left? If I said left, I made that mistake. It goes to the right, and then it goes down to 1. So it goes to the right, and it goes down to 1. So this is the transformation. It goes down 1 to the right. This is going to go to the right. 1 right, 1 unit, and then down 1 unit. So in this case, to the right, it's only A and it's B. The other, A and C. So we know that B and D are incorrect. This one's going up, so the answer is A. So this is wrong. The answer is A. Let's go ahead and do number 9 the same way. So once again, we're going to describe the steps that we go from the square root of x, which is f of x, to g of x. So I'm going to use my calculator. We have y equals. Now the parent function is going to be a square root function. This is a square root function, and I'm going to go ahead and clear this. every number in this equation is going to do something. For example, that 2 there is going to do a vertical stretch, and then that negative there is going to do a reflection, and that x plus 2 is also going to do something. So we're going to go ahead and see what's going. I think this time I'm going to use the trace button. The trace button may be able to show you the transformation better. So here is the parent function, and here is a trace button, and you notice that that negative is going to reflect it over the y-axis. The 2 is going to shift it to the left, and that 2 in front of the radical is going to go ahead and do a vertical stretch. So I expect you to draw this to the best of your ability. So remember, this is your y-axis, this is your x-axis, this is the parent function. And you notice with the new function, it shifted 2 units to the right. To the left. I apologize, to the left. And then it looks something like that, right? Of course, you want to curve it better. Of course, it's a sketch. So now we got to check from each of those answers which is correct. We know that it's going to go to the left. So this is translation to the right. This is left. This is left. This is right. Compress horizontally by a factor of 2. But this one says reflect over the x-axis. It doesn't reflect over the x-axis. So your answer is C. Your answer is C. Reflect across the y-axis. Expand vertically by a factor of 2. And then translate to the left 2 units. To find the possible factors for this polynomial, you have to find the factors of the constant over the leading coefficient. So for example, the constant is 15, so plus or minus 15, plus or minus 5, plus or minus 3, plus or minus 1. Those are the factors of 15. And then of course the leading coefficient is plus or minus 2, plus or minus 1, and then you start dividing. So we have plus or minus 15 over 2, so that's there. Plus or minus 5 over 2, that's there. Plus or minus 3 over 2, that's there. Plus or minus 1 over 2, that's there. And then the rest you're just dividing. 15 over 1, that's 15, it's right there. 5 over 1, that's 5, that's there. Plus or minus 3, that's there, and then 1, and that's there. So your answer is A. That's how you find the possible rational roots. To condense this expression into a single logarithm, we're going to have to rewrite it. So that's what I'm going to do right here. Then I'm doing 44. So you have log base 6 of c plus you have the 1/2 log base 6 of a plus the 1/2 log base 6 of b. Remember that the 1/2 can be raised as a power. So you have log base 6 of c plus log base 6 of a raised to the 1/2 plus log base 6 of b to the 1/2. And remember that if anything that is raised to the 1/2 or anything that has a fraction, it's a root. So you have the log of b of c, the log base 6 of c plus the log base 6, and this is going to be square root of a, plus a log base 6 the square root of b. And now we're going to use the multiplication property to combine it into a single logarithm. So we have log base 6, and then it's going to be the product c, and then you have the square root of b times a. So your answer is D. Number 43, we're going to make it to a single log. So what you have is 6 log base of 8 of x minus 4 log base 8 of y. We're going to use the power property. So we have log base 8 and we have x to the 6 minus log base 8 and we have y to the 4th. Remember that if they have the same base, in this case they do, and they're subtracting, we're going to use a quotient property. So we have log base 8 and we have x to the 6 divided by y to the 4th, and that's a single logarithm, so the only one that satisfies that is C.